Good day, everyone. This is Professor Friday coming at you one more time. Today we're going to be doing a little bit of pre-calculus. Today we're going to be graphing using transformations, and the function that I have for you today is y equals 2 times the square root of negative x plus 6 and square root minus 1. So the technique of graphing using transformations is to identify a parent function, or as I prefer to refer to it, a mother function. Just can't say that without getting a smile on my face. This bad mother function is whatever cannot be explained up here by one of our transformations. Now, from our library of functions, the function that we will be using to start will be y is equal to the square root of x. So in addition to knowing what the function is, knowing a couple of points that are on that function will probably be beneficial. So what we're going to do is pick just a few points that have really nice square roots, and we're going to talk about how to transform all of these points. So next thing we're going to do is identify the transformations based off of the algebraic operations that we see happening to either x or to the radical itself. So I encourage you to put them in the following order. The order is H, S, R, and V. H stands for horizontal shift. Horizontal shift is when we see something added or subtracted directly from the x variable. S stands for stretch or shrink, which is from multiplication by a constant, a positive constant specifically. Reflection is from multiplication by -1, and V stands for vertical shift, which is adding or subtracting from the mother function rather than from the x variable. So what I'd like to do is identify each of our transformations. Horizontal shift, we said, is from addition or subtraction directly from the x variable. In this case, there is a +6. A +6 is balanced out by a shift to the left. X tends to be the one that winds up looking backwards with regard to whatever we see. We said that S, stretch or shrink, comes from us multiplying or dividing by a constant. Our 2 in front is referring to a stretch in this case. Now, when it comes to vertical versus horizontal, we notice that this one is happening outside of the radical, so it's happening to our actual function, not to the x values. So that one's going to be vertical. So we'll point out that this will be a vertical stretch by a factor of 2. If that happened to be a fraction, that would wind up being a shrink. Regardless, you can refer to it as a dilation. For a reflection, we said that this is multiplication by -1. Which in this case we see a -x, so that is going to be a horizontal reflection. Now the one that is a little bit confusing with this is that we refer to a horizontal reflection as being over the y-axis, because when things move horizontally they are crossing the y-axis. And finally, vertical shift comes from addition or subtraction of a constant, not directly to our x variable. So in this case, this is going to be down by 1. All right. Now we get to actually make these transformations happen. What I'm going to recommend that you do is, starting with the thing that we had back here, I'll just make a little table of our x values and our y values that are associated with this square root function. So right here, this would be y is equal to the square root of x. Now what we're going to do is start building left and right on this thing. We build to the left as we transform the x variable, and we build to the right as we transform the y variable. So to make the distinction between x and y, let's even double this one down. So as far as horizontal is concerned, the two transformations that we have are to the left by 6, and then a horizontal reflection. So let's do left 6 first, and apply our horizontal shift. All of our x values are going to get shifted to the left by 6 units. That is a subtraction of 6 units. So subtracting 6 units from everything listed, 0 will become -6, 1 will become -5, 4 becomes -2, and 9 becomes +3. Then the only other horizontal transformation that we have is a reflection. Reflection is simply, let's multiply by -1, and that'll be what we get. So we will negate the signs for all of our x variables. Now, in the other direction here, we have a vertical stretch by a factor of 2. So all of our y values will be doubled. 0 becomes 0, my favorite multiplication. 1 becomes 2, 2 becomes 4, 3 becomes 6. And then we will also have a vertical shift associated with this. We said that the vertical shift is down by 1. That will subtract 1. Oh, that's not how you spell positive 1. Hang on. There we go. Much better. There we go. Keeping things positive. Shifting things down by 1 will subtract 1 from the corresponding values of y. Now, as far as points on the actual graph are concerned, we're going to take all of our transformed points and put them together here. So x values of 6, 5, 2, negative 3. Y values of negative 1, positive 1, 3, and 5. Now, for purposes of graphing, I like to let my students know that I will actually provide them with some graph paper, but since I'm at home and all my graph papers in the office, we get to improvise a graph. So there's 5, 3, 1, and negative 1. Oh, those are all the y values. I suppose I should probably put down the x values, huh? 6, 5, 2, and negative 3. And then we'll put down the corresponding y values of negative 1, positive 1, positive 3, and positive 5. Give that one a little oopsie-tootsie. So, the points that we have 6, negative 1. 6, negative 1 will be right about there. 5, 1. That should be right about there. 2, 3. And then a negative 3, 5. Now, I know, because I studied super hard this weekend, that the square root function is supposed to look like half of a sideways opening parabola. And what I can envision here is that this thing looks like it's going to be opening to the left. So keeping in mind that our typical square root function looks like half of a sideways parabola, we also want to know that 0, 0 would have been the vertex. Following 0, 0 through its transformations, we see that the so-called corresponding point for 0, 0 would be 6 and negative 1. So that should be where your vertex style point is on this half of a parabola. I missed. There, I made my target bigger and now I didn't miss. So this would be what the graph of y equals 2 times the square root of negative x plus 6 minus 1 looks like. For some additional credit that I frequently like to offer, I like to take a look at the domain and the range. I notice that because of the arrow to the left here, terminating at 6, domain is going to be from negative infinity up to positive 6. We actually hit 6, so we use the square bracket there. For the range, we go as far down as negative 1 and as far up as positive infinity. So, hope you found this informative, and I'll see you for the next video.